Hello everyone. This is another topic in electromagnetics and transmission line. We will look at the power driven to this transmission line with characteristic impedance 0, and in the end we typically have a resistor with matching characteristic impedance, and we know that if we have a resistor here, the all the power goes into that termination. There is no reflection of the power. What if I replace this terminating resistance with a pure reactive element? It's either a pure inductor or a pure capacitor. If it's a pure inductor, then its impedance can be written as J times of X, and if it's a pure capacitor, it can be written as minus Jx. For example, in case of an inductor, if of inductance value L, it's going to be J omega L, and in case of a pure capacitor, it's going to be 1 upon J omega C. In both the cases, if we take J up, then it becomes minus 1 upon omega C. We can represent it as Jx or minus Jx. It turns out that if it is a pure reactive element, then all the power that is incident on this transmission line will be reflected back. And this is something we are going to prove in this solution. If you want, you can stop this video and try it yourself and then possibly proceed on this. What we make use of is the formula for the reflection coefficient. Rho is given by ZL minus Z0 divided by ZL plus Z0. So, and the next thing that we make use of is the reflected power formula. So the power reflected, let's call it PR, will be given by half of mod of voltage reflected square divided by Z0. And this we can write as half of, now what is this reflected power? Reflected power will be given by rho times of incidence power, which we calculate VI whole square divided by Z0. This is our reflected power. And then we can find this rho, let us call it mod of VI whole square divided by Z0 multiplied by mod of rho whole square. And rho now here is a complex quantity. Even though Z0 is a real quantity, we have ZL as a complex quantity, and we can write it as half of mod of VI square divided by Z0. This we can write as, let us take only one case, Jx. So this is J times of X minus Z0 divided by J times of X plus Z0. And we can simplify it to, we are trying to make the denominator a real number, so we will multiply it by Z0 minus Jx. And this will become Z0 square plus X square. And this, if I multiply it by, this becomes Jx minus Z0 multiplied by Z0 minus Jx. And this can further simplify it to minus of, this is Z0 minus Jx whole square. If I take this minus sign out, it becomes Z0 square plus Jx square is minus X square, and then minus 2 times of Z0 X into J divided by Z0 square plus X square. or I can further simplify it to x square minus z naught square and then plus 2x z naught j divided by z naught square plus x square. This is our rho, and rho in this case is a complex quantity. And now we have mod of rho whole square can be written as rho into rho star. This is from the theory of the complex mathematics, rho into rho star, where rho is this value. If we multiply this rho and its complex conjugate, we get the value of mod of rho square. And if you look at this term, half of mod vi square by z naught, this is actually the incident power that we can write is at P incident multiplied by, and rho is this much multiplied by rho star. So the rho star is going to be x square minus z naught square minus 2x z naught j divided by z naught square plus x square. And if I multiply these two things, we get on the denominator z naught square plus x square whole square. And then in the numerator, we get x naught minus z naught square, x naught square minus z naught square whole square, x square minus z naught square whole square, and then minus 2x z naught j whole square. If I can simplify it, this whole thing becomes x square whole square, x square whole square plus z naught square whole square minus 2x square z naught square, and this thing becomes 4x z naught 4x z naught square, x square z naught square, and j square is minus 1 into minus 1 becomes plus. So this is our whole term divided by z naught square plus x square whole square. And if you look at closely, is minus 2x square z naught square plus 4x square z naught square becomes 2x square z naught square, and this whole thing on the top side becomes x square whole square, a square plus b square plus 2ab. So you can write it as pi multiplied by x square plus z naught square whole square divided by x square plus z naught square whole square, and this becomes equal to pi. So the reflected power is the same as incident power, which means all the power that goes into this transmission line, if it gets a pure inductor or a pure capacitor, all the power gets reflected back. In reality, what will happen is this inductor or the capacitor will have a series resistance. It's a parasitic resistance or a parasitic resistance either in capacitor or the inductor, and therefore some of the power will get dissipated into the load and not all of the power will reflect back. We'll keep doing some more problems on the transmission line, and we should practice more such problems to get a hold on the transmission lines.